Thank you for attending this afternoon. Hopefully we can tailor this to what you're interested in, because I could talk about a lot of different things. Just as an introduction, I wear many hats. I'm the chairman of the board for the OpenStack Foundation, so I spend a lot of my time as a volunteer with OpenStack. I'm also on director on the board of directors for the Linux Foundation, so I spend a lot of my time working with Linux and the kernel guys and so forth. And then my day job, I get the guys that give me a paycheck, though I don't do much work for them. I shouldn't say that with a microphone, should I? No, they know that. My day job, I work for Susa. And they actually hired me to spend my time with these industry organizations. So I've worked with GNOME, KDE, OpenSUSE. I could name 100 different projects where I've participated in open source, and I've been involved with open source for many, many years, as you can tell from the gray hair. But I wanted to start out, it was an interesting thing. The Linux Foundation did a research paper late last year, and they asked technology vendors, what are the technologies that are going to be of interest to you next year, 2015? And a couple of things that came out of this survey. One is these top 5. The other thing that came out is within the survey, when they were talking to these technology companies, they realized, and we've all heard the pitches, right? We got to do things faster, smarter, and for less money. And so one of the big motivators for technology companies is they want to spend less money on research and development. They want to get their products out faster. And they're finding the way to do that is through collaboration, okay, which turns into most typically open source collaboration. So as we look at these top 5 that they named, interestingly enough, all of these are being done out in the open source world. The one that we want to focus on is cloud computing. We're going to dive as deep as we can in 45 minutes here. But I want to talk about OpenStack. And if you're not familiar with it, OpenStack is infrastructure as a service computing. It's an open source project started about 5 years ago, formally put under a nonprofit foundation 3 years ago. And this is our mission statement. We're trying to produce a ubiquitous open source cloud computing platform that meets the needs of both public and private cloud, okay, regardless of their size. So we've got some implementations that are very small, just a few nodes, up to people like CERN that are, I can't remember how many nodes he told me he has now, but just hugely scalable. So it's got to be scalable, it's got to be simple to implement, and independent of size. So we keep, and if you've seen OpenStack presentations, people will always come back to this mission statement because it affects the way we design our software, okay? So you're going to find we have lots of pieces and parts, and you've probably seen charts where they draw all these little lines and say, oh, it's very complicated. Well, part of the reason it's complicated when you start breaking it down is because we want to make it scalable, right? So we're trying to break things apart. Now, interestingly enough, OpenStack has gained huge momentum in the last 5 years. We have over 500 different organizations that are sponsoring OpenStack. That means they're giving some type of monetary value to it, either be resources of people, time, money, energy, right? So they're not just saying that they're part of OpenStack, but they're actually providing something to the project. 23,000 members that are participating from around the world. It's been labeled, the Linux of the cloud because it has a very similar look and feel to it, right? It's multinational, very much independent. It's not controlled by any single entity or any single company. And then if you look at it in terms of size, it's very similar to Linux as well. The trajectory of it is much faster than the Linux kernel was. The Linux kernel is over 20 years now, But when you look at them, they're very comparable to date. Pretty cool. So what is it that gives its competitive edge? So why is it that we've got 500 organizations that are participating in OpenStack? One of them was exactly what I mentioned that came out of the Linux Foundation report. It takes you less time to get your product to market, right? You can get there faster. You can reduce your engineering costs. You can reduce your development costs. But an interesting thing that came out of this study as well is that these companies found that they were having a better relationship with their partners and with their customers, because those 23,000 members that are part of OpenStack aren't all developers, okay? A big chunk of those are actually people using the code. And it's kind of, sometimes it seems a little counterintuitive going, well, why would my customer be there? Well, they want to see how the code runs, okay? I learned this a long time ago from the Linux kernel guys. We used to hold an event in New York City focused on the financial services guys. Those guys are there. They didn't actually want to change the code, but they want to understand exactly what the code is doing so that when they build their applications on top, they can take full advantage of it, okay? And they would come and they provide the kernel folks, and they continue to do this, provide the kernel folks their input on what they actually need, and so forth. So it builds that relationship. And then the next one is that they're finding they can innovate faster out there in the open. So you share an idea and you get other people to help you transform that and help it grow. And so we're finding that a lot of the new industry innovation is happening out in open source land because people are collaborating together and can do it in this open way, make it go faster. And then the last reason here is the openness, right? It's the ability to come in if we need to. You can modify the code, and you can influence its development. So that's why they're there. We just released Kilo just in April, so we're in May now, so a couple weeks ago. A lot of new stuff that happened in Kilo. This is our 11th release. Pretty excited about this one. A lot of new stuff, as I mentioned. But the big theme around this has been that we've had so much growth, so much code change, so many new components that have been added in. We've been getting feedback from our users going, whoa, this is a lot. We need to make sure this is stable. There's a lot of new changes coming in and a lot of new components. You know, what's the stable stuff? What's the pieces that I can use, particularly for my key services that I need reliability. And so we've been focusing on that for a couple releases now. For Kilo, this was a very strong main theme. And I'm going to talk a little bit about that more in just a second. The second theme is interoperability. So we've been pushing one of the OpenStack strengths, right? Because there's big guys out there, right? The Amazons and Microsofts and so forth, they're big in cloud, right? How do you compete with that? Well, the way we compete with that is to get interoperability between all our vendors, right? So on that previous slide, what is it people are looking for? They're looking for that openness, right? So they want the ability to choose the software and choose the vendors. But when you do that, you need interoperability. So our strength from our community perspective is to build interoperability so that it doesn't really matter whether you get the cloud from Susa or Red Hat or Rackspace or Mirantis. I noticed Mirantis is here, so forth. You're going to get that interoperability. So from a user's perspective, you're really looking for this. We introduced some new features, some of the things that we've been working on. For example, Ironic, which gives us bare metal provisioning so we can start from scratch. We're going to delve into this a little bit here in a second. We've also been working on other emerging technologies such as containers. You've probably all heard of Docker, for example. And building the platform to support platform as a service, big data, or some of the other things, and of course NFV and software-defined networks. So NFV is huge for the telco guys, and we're pretty excited about this area. And I'll show you a slide here in a minute about that. All right, so as I mentioned, the community continues to mature. One of the things we focused on was a discussion we started 2 years ago actually. People started saying, there's so many things coming into OpenStack. What is OpenStack? What is it really, right? And so we thought it'd be really simple to define, okay, what's core? What's this core piece of OpenStack? Turns out it's much harder to define than we thought. But we're rolling that out now. So we've reached a milestone here. Like I said, one of the things we're after is interoperability. And we want to not just say it's interoperable, but we want to be able to test for that, and so we can give users some comfort that they are going to get that interoperability. So we're rolling this thing out. It's the latest iteration is called DefCore. You won't see that from a user's perspective, but as a vendor, you'll see that under the nomenclature called DefCore. Basically what we're doing is we're defining a set of capabilities. We're saying, okay, these capabilities are required. If you're a commercial product, you're going to use the OpenStack label, you have to have these capabilities, okay? So a capability is a thing like I want to spin up a service, okay? I want to launch a virtual node. I need to create a user, okay? Those are capabilities. So we've started with a small set. We specifically wanted to start small. We knew we would grow, but we wanted to start small. We've now defined that, and we've defined the tests that go along with that. So vendors, and you'll see a bunch of announcements. When's the summit? 2 weeks? In 2 weeks, announcing that they are compliant with this testing. So the vendors now have to run those tests and show that they pass those tests to wear the OpenStack label. Okay, and our intent here is to drive that interoperability and to drive consistency amongst all the vendors that are part of OpenStack. So then we've got, from that, we've got some usage patterns that are emerging, and I'll show you what some of those are. They're pretty interesting. A lot of new ones are focused on the big data folks, which is a very interesting use case. I started talking to those guys a couple years ago, and when I started talking to them, they were like, I don't get cloud. I just want to burn up as much CPU and hardware as I can get, right? I'm just there to chomp on data. But as the definition and use of big data has grown, they're branching into new areas, and they're recognizing, hey, I could do that in cloud much more efficiently. So that's happening. So at the same time as we've got usage different new use cases emerging, we've got to refine what OpenStack is focused on and developing, and so we're doing things like we've just launched a product management effort, right? So typically open source, you have developers working on code. Those developers have what we call a hidden manager, right? Somebody back in their office that gives them a paycheck, like me. I got a manager that gives me a paycheck, and he's telling me what to do and what I can work on and what I can't work on. So we get all these developers in the community, they're working on their favorite thing. At the same time, as a community, we recognize there's things that we really need to be working on. So we need to go back and influence those managers and say, we really need your engineers to work on this. And so we've got a new effort that launched about 6 months ago to focus on the product managers from the vendors to get together and start discussing what the priorities should be. At the same time, we've also got focus groups that are working in particular areas. We've got a group that's focused on the enterprise. So private cloud, what are the enterprise needs? We've got a group that's focused on the telcos. This is the NFV work. And what are their requirements? And so forth. So we've got different groups that are looking at the issues. So the next topic here is, as I mentioned, we've got all these components that are growing, and OpenStack continues to grow. So when we started, OpenStack was 2 components, right? Compute and storage. Those were the two components. If you look out there within OpenStack itself, there's over 25, 26, there might even be 27 now. There's new ones that pop up every day. New little projects that get started up. Some of them never make it to what's called the integrated release. Others are there and need to be split and so forth. So this thing is continually evolving. With this release, there was 12 components that came out, depending on how you count them. And as you realize, if you've ever tried to project manage a release, the more components, the more complex it is, and the harder it is to actually hit your release date. And so there's been a lot of discussion at the technical committee as to, do we continue to try to do a 6-month release? What does an integrated release really mean, and so forth? And so they've been working hard on this, and this rolls back to the core definition, right? We've got some of these pieces that are new. For example, ironic is new. We've got some of these other pieces like compute and storage, which are core. How do we differentiate those to our users so that they know, okay, ironic is new, maybe a little raw, but these other pieces are stable. So you're going to see a lot of discussion over the next 6 months over this thing called our integrated release. So the next release, Liberty, what does that really mean, and so forth. And the second part of this is we wanted to open up the door for additional innovation. So projects, for example, Celiometer, which is our metering and monitoring tool, needs some innovation, right? There's a lot of discussion about, is it going to be able to scale to the size that we need? And so how do we innovate without breaking that stability? Do we need to fork it, create a new project? What do we do? And there's been if you've seen the mailing list, there's all kinds of discussions around how do we do that. And so that's part of this integrated discussion. So we want to open up the door for innovation while providing the users this notion around core about what's stable and what's mature so that they can depend on it. So a little statistics here before we dive into the architecture. So we had about 1,500 people contribute code out of about 170 organizations. And I use the word organizations instead of companies because we receive code not just from for-profit companies, but also from nonprofit organizations, including universities, labs, research labs, governments, and so forth. So Kilo was a 6-month effort. Out of that, we had about a little under 400 new features, which is about typical for each one of those releases. That's a lot of features, representing about 7,000 patches, and a whole bunch of languages. And we're up to about 100 and over 100. Yeah, I know it's more than 113 different drivers and plugins, and I'll show you what those are here in a minute. Okay, so let's look at a slide here. And I apologize, I was redrawing this yesterday, and so it's still a little bit of a work in progress because I needed to update it. And so as I mentioned, there's a lot of different components within OpenStack, and we don't have time to talk about all of them. But what I maybe can do is characterize them as different layers. Now, a couple things, like as I mentioned back on the mission statement, right? We wanted to make this scalable, okay? One of the things we've learned about as we've grown within OpenStack is one of the ways to make that scalable is make the components pluggable, okay? And it's not only just for scalability, it's also to be able to focus it on a particular use case, okay, or a particular market. A good example of this would be in compute. So compute is extensible in the fact that you can plug in all the different hypervisors or container support, right, for virtualization. But it's also extensible, and we're continuing to build on the extensibility so that you can change the scheduler. Okay? Now, when we started, scheduling was just scheduling. But over the releases, we realized that the way I do a cloud, if I'm doing a cloud for storage versus a cloud for compute, versus a cloud that is geographically dispersed, that affects the way I want to schedule my resources. Okay? I want to schedule those nodes within my cloud, the way I set up regions and so forth. So we've made it so that it's pluggable so that I can extend that scheduler and tune it the way I need it. Okay? So these components, a lot of these components are all scalable. Well, not just scalable, not scalable, pluggable in a sense. And that's even a loaded word. I use the word pluggable within the community. Some people go berserk, because pluggable means different things to different people. But let's look at these layers a little bit, talk about them. So as we look at the top layer, this is what I call the service management layer. This is the layer that you view into OpenStack. This is your dashboard, right? So you either have your API interface, your command line interface, or your graphical view, which would be the dashboard. So this is my dashboard. This is where I get the graphical view of my cloud and can see all the services that are out there deployed or readily available or whatnot. Okay, so this is my graphical view. Turns out that and I can name several environments, manufacturing environments, very typical. For example, they don't do a dashboard as much as they build this software into their processes. Okay, so in an enterprise environment, for example, they'll have an administrator that'll use the dashboard, but the rest of the company, they don't see it. What they do have is they have their own processes that they've built out that implements all of their policies. Okay, and so they come in through the APIs and the command line interface, and they build this cloud into their corporate policy. Okay, so example is I call up the help desk and say, I need a lamp stack, right? The help desk doesn't go to the dashboard, they go to their in-house, typically it's an in-house software package that says, fire up this guy lamp desk, sends off the message to IT or whatever. They've modified it so that it now just launches an instance. Okay, so it's built into their process, into their build back and so forth. So that's the service management interface. The next layer is what's called the service interface. And if you remember the cloud layers, this is infrastructure as a service. On top of this, you can typically have platform as a service. So platform as a service needs services from internet as a service, such as database. Okay, be able to launch database as a service, for example. They need queuing. Okay, the big data guys need data processing. And so it's not that those services are built into this layer, but the ability to launch those services are built into this layer. So it's a service interface. So the big data guys say, I need to launch a big data service. It's the infrastructure as a service that will launch Hadoop or whatever they're trying to do at that point. Any questions on that so far? Okay. The next layer is the orchestration layer, and this is the brains. Okay, this is where we begin to get the benefit of cloud, because we talk about cloud of shortening your deployment time from weeks and months to minutes and hours, right? This is where you get this ability is in the service layer. One of those pieces in here, is the orchestration piece, right? So this is the piece, actually, let's go to the metering and monitoring. The first piece here is the metering and monitoring piece. This is the piece that sits in and listens to all the other components and what's going on within your cloud, right? Am I hitting high water marks, low water marks? Has a service died? Have I lost network connectivity? So forth. So it's metering and monitoring that, and gives me an alert when those thresholds are met. The next piece here is the orchestration piece. This is the piece that gives you that automation, right? So we talk about agility and automation. here's where you get your automation. So from your metering, you get some type of an alert. It's the orchestration that kicks in and says, okay, here's what I'm going to do about it. Okay, so and then I set up my policy according to the orchestration to say, well, you can within these bounds. Okay, and that may include deploying something new, either an in-place deployment. I just add a node to my cloud, or it could be that I'm going to start fresh and I need to add a new machine out of the box kind of stuff. So that's my orchestration piece. So that's the brains, right? That's the guy that's giving me the smarts in my cloud. The muscle for the cloud comes in the next layer, which is the capacity management piece, which is the traditional pieces. So this is the workhorse engines. This is the heart and the muscle. And these are the three typical pieces of this is the compute, which is where I get my virtual machines, right? This is, when I say go do work, it's the compute pieces that's doing work. Another piece here is the networking piece, and networking used to, when we started, networking was actually part of compute. And it was pretty simple, right? It was basically set up my network and give me an IP address and away we go and so forth. But as clouds have grown, and particularly as clouds have grown to cover the world, geographically dispersed, the needs for the type of networking services has dramatically grown. And so networking was split out into a new component and has been maturing since that point. And again, a big requirement for that is extensibility. And then the third piece here is storage. And there's different types of storage that are needed. First off, we needed to be able to store images. And the images are the workhorses, right? So when we say, hey, I want to create a lamp stack and run a lamp stack, I've got to have an image of a lamp stack to run in my cloud, right? So I need to store that somewhere. And so I had to have some storage for that. And I needed to know how to get to it and how to retrieve it and so forth. I needed block storage. I needed object storage. And a new one that's coming along is shared file storage. So again, a new area that continues to grow. So those are the three workhorses. Now, to manage all this, to manage it securely, then we needed additional services to handle the security. So we needed key management, and then we needed ability to do authentication and authorization, right? So we have a policy that covers this. So let's say from the dashboard, I say, hey, launch me a new lamp stack and launch it in Salt Lake City. First off, I needed to know, who are you? Secondly, I need to know, do you really have the rights to do that? Okay. And it's the authentication and authorization that gives me the identity and checks my authority to see if I can actually do that. And then again, I'm also asking, and which can he really do the lamp stack and which lamp stack and so forth. So goes into the policy, says, can I do that? Finds the image, gives it the compute node and says, launch that service for him. So that's what ties in the key management and authentication piece. Now, the next layer down is what I call the abstraction layer, and as you can see, I threw boxes off of the main compute network and storage pieces. And this is dramatically growing as OpenStack continues to evolve. One of the first things that happened several releases ago, I think it was clear back in Diablo, might even been in Cactus. They recognized the compute module was getting big, and they said, well, one thing, compute was getting really big. Two, network and storage were people were copying and pasting the code into the different components. And they went, that's not a good idea. So they started pulling out code and putting it into what we call the shared services libraries. so that we're not repeating code that unnecessarily. So some of these services now have been abstracted away from where they originally resided. But the second part of this is we needed to abstract away the cloud services from the underlying hard facilities, right? So we needed to abstract them away from this to give us that flexibility to operate on multiple architectures, anywhere in the world, data centers or what have you. That's where it started, right, with the different hypervisors. So OpenStack supports all the different hypervisors you can think of. It seems like Hyper-V, Xen, KVM, VMware's ESX. And as of the last three releases, we've had some support in there for containers, so it's a lot stronger, like I mentioned now in Kilo. As that technology matures and solidifies, we got some new specs that have just come out as well. So we needed that abstraction from the hardware facilities that lie underneath. Also, as I mentioned, in the networking space, networking used to be very simple, but it's now grown. I got a typo in there. No, I don't. To include other services, we needed load balancing. So we've got load balancing as a service. We needed to be able to have DNS services. So we've got DNS as a service, firewall services, and then as of late, software-defined networking. So we tie in that capability through other projects such as Open Daylight. Okay, and then beyond this, what I don't have pictured on here is, as you look at each of these extensions, what you'll find is there's actually drivers that tie into those. A good example of those would be in the SDN space, in the networking space. So when I mentioned before that there's like 115 drivers, a lot of those have to do with such as networking and storage capabilities. So you add on the drivers on top of those. So there's a lot of complex pieces that put this all together. And well, so before I go on, any questions? Is that a fire hose for 3 o'clock in the afternoon on a Friday? Okay. So going back to these just really quick, because I thought there's no way I can tell you all the features of all the components. That'd be a week seminar. We can't do that in 45 minutes. So what I thought I could do is just tell you a couple of the things that have come out in the Kilo release. So as I mentioned, we've got bare metal provisioning that's come out. There's a new API version, so it's API 2.1 that's part of the compute module. And we've done some operational improvements, really working hard to get to where we can do live upgrades. Okay. And so we've done a lot of work in that area. Been doing a lot of work, it's not listed on here, but there's been a lot of work in the area of cells and regions. In storage, a lot of work in the area of storage for containers and in cluster replication storage, updates in the block storage. A lot of it had to do with testing. Again, particularly with the drivers on the back end. So all the NetApps and the EMCs and VMwares and all those guys that have got storage drivers for your hardware. And then the third area that there's been a lot of work on is around the notion of high availability. So both in the compute module and storage, there's been a lot of work within the community in high availability. Vendors have been shipping this, including Susa, and those vendors, including Susa, have been contributing that technology and those patches back into these releases, and so they're starting to show up now. Okay, networking, load balancing as a service. We're up to version 2 on the API. We've been adding in a lot of support for NFV. And a lot of that has to do with reliability and scalability, but so we need things like the VLAN support and the scalability for identity, particularly identity federation is a big theme. You're going to see some announcements around that in the summit in 2 weeks. And then again, more additions for high availability so that we can get support in there through what's called Heartbeat, or you've probably heard of it as Pacemaker. Okay? All right, so we have all these features, all these people working on all these different components within OpenStack. Seems like it could be pretty much chaotic, right? And what's very interesting about open source is, as I mentioned, we got all these organizations that are contributing, but they all come in with a very different business model. Okay, they have a very different focus, a very different purpose that they're trying to use, how they're trying to use OpenStack. And I think it's very cool that everybody comes in here. Some of them are competitors, right? So I can look at this again. Susa, Red Hat, Ubuntu are probably direct competitors, whereas IBM, HP, right, would be competitors, yet we're there working together. So even though we have different business models and different market focus and so forth, we found this commonality where we can work and share together. So what you'll find is that they'll take those pieces, go back to that architectural chart with all those layers, and they will tune that to focus on the markets, the particular markets that they're after. So, and I can't go through all of them, but just to give you an example, so Susa, see, is part of OpenStack. They've got a three-prong cloud strategy. They are not in the public cloud space, okay? Well, they are, but they're not a public cloud provider, okay? So we leave that to the IBMs and the VMwares and so forth, and the Amazon. So you'll see SUSE deploy services and have its enterprise server available in public clouds like Rackspace and IBM and there's like 50 of them, Amazon and Microsoft and Google and all of those guys. In the private cloud space, they actually do ship a product, and it's based on OpenStack. So it is part of OpenStack. And then we supply tools for the hybrid cloud space so that you can migrate your workloads between public and private and vendors and so forth. So what I wanted to show you is this picture, and it's a little bit dated. I apologize. I need to actually update this because I'm a release behind here in the picture. But if you think of that architectural picture I showed you of OpenStack, there's some components that are missing. And has anybody tried to go out to OpenStack and compile the code, and build it and run it, install it? It's a task. It's pretty hard, okay? Because it's not 100% complete. There's actually pieces that aren't there. They'll probably get there over time, but they're not there today, okay? So this is a picture from Susa, from the software that they ship. The orange pieces here are the pieces that come from OpenStack. So they take all those pieces that come out of the integrated release, okay, and they bundle in additional open source software that's needed around it to and ship it as a product. So they'll take it off, they'll take the release, test it, harden it, make sure it's going to work in the environments that they're focused on as a company, okay, and deliver it to their customers. So one of the areas they focused on is making the install easy, okay. Secondary, put in the database services and the queuing services that are needed for this. And if you remember in that architectural picture, there's all kinds of abstraction support in there, right? So virtualization, all the different types of virtualization. Not all vendors support all virtualizations, okay? One of our competitors focuses on KVM, and that's the market they're focused on, is the KVM environment. Susa has a lot of customers that are still running Xen. Actually, Xen's making a comeback, interestingly enough. So they include support for KVM and Xen, VMware, and Hyper-V, from their experience working with Microsoft all these years. They've added in my pictures behind, they're adding in support now for Docker and so forth. So you'll see vendors, now you can start to see that picture of why I was talking about the need for interoperability. You have to have that core and say, okay, got to have that core that everybody's going to support, because some vendors are going to support some options, others are not. Okay, so with Susa, you're going to get support for all the different hypervisors. Other vendors you're not, but we'll all have the same core, right, capabilities. So they've added all that support in. The pieces that are missing here would be things like high availability. They've added in additional support for high availability because we had or have people like air traffic controllers and financial services, right? For those guys, services going down means nasty, bad things. And so they needed that reliability. So what you find is if you go out there, and I just took a sample of our marketplace, right? All those different vendors are out there. They're focused on different things, right? So we've got companies that are out there that are just focused on training. We've got people that are focused on being a distribution of OpenStack. We've got public providers that are doing public clouds. We've got hosted private clouds. We've got companies that are focused on services. We've got companies that are focused on doing just network and storage drivers, so just particular components within OpenStack, okay? And so all these different companies coming together. And if you start to look at the markets that they're focused on, how are we doing for time? We're almost out of time. This was a survey, so this is just a quick glance. You can see some of the markets, IT, information technology, so private cloud market is huge for OpenStack. That's a big market for us. All these predictions that private clouds are going away and all IT departments are going away, it's all going to the public cloud. I'll bet you money on that one. It ain't going to happen. So government, defense, finance, film and media is huge. Very interesting use case. Manufacturing, energy, consumer goods, retail, healthcare. I wish we could sit and talk about all of these because they're really fun use cases. They're very different. Insurance, transportation, tons of different markets where these that are using OpenStack. The drivers, the ability to innovate was the number one answer was, what's that? I don't remember that show. Anyway, ability to innovate, why they're using it, open technology, saving costs, they're avoiding vendor lock-in. This is that interoperability, right? Operational efficiency, the flexibility of the underlying technology choices is another big one. All those drivers, all those different vendors with the drivers and plugins and so forth. Time to market, the ability for them to attract talent, and the last one there is the ability for them to have control over their environment. Those are the drivers that are driving people to OpenStack. So why OpenStack? From a business perspective, I'm growing my business. It's typically not that I just want to change my technology and do something new because the cloud is the buzzword. That just doesn't happen. What they're really trying to address is their business is growing and they're finding this is the way to do it, because the second thing there is it gives them that technical agility and gives them efficiency. Particularly from the IT department, what we found is in a typical IT department, 80% of their time and staff is spent on just trying to keep the lights on, doing the maintenance work, right? And so they're always looking for ways to reduce that so that they can get on and do more innovative things, right? And the new and innovative things. So to do that, they've got to get better agility and efficiency. And so they're looking for a way to do that in a cost-effective manner. The next one is rapid elasticity. as I mentioned, all these use cases, one of the biggest ones that's looking for elasticity is our retailers, right? Their use case, their usage goes up and down with daylight and darkness and holidays and so forth, and so they need to respond to that very, very quickly. And we could talk about some interesting use cases there. So they need that elasticity. They also need the flexibility. And then the last one here, which is a very interesting discussion, is this notion of called shadow IT, which basically says, I as a business manager have a credit card. It used to be that I was trapped and was forced to tell IT what I needed, and they would tell me what they would give me. Now with my credit card and public clouds out there, I can just vote with my credit card and say, screw you IT, I will just go and fire up my service on Amazon. And so the IT department are responding to that in a positive way, and it's been very interesting to watch that. It's improving, and when they do that, several things happen. One is communication. Two, we're redefining the role of IT within the business. They're no longer just this department that I have to go to get my latest computer up and running, but they become a partner in a discussion of the types of services that I actually need and the types of services that are going to better service my customers. Okay, so anyways, if I just throw this slide up, going out to OpenStack, you can go out to OpenStack, you can download it, compile the code, and give it a try. Could be very hard. If you want to try it, a real easy way, just go out to this link here. It's compiled in what Josh and I were talking about earlier. It's already built in an image, so you put it on a USB stick, plug it in your laptop, bring it up. And at least on your laptop, you're not going to bring up a cloud. I don't see anybody here that's got a laptop that beefy, but it brings it up enough that you can at least see what we've been talking about. Okay, and like I said, it's really easy. You can just put it on a USB stick and give it a try. And with that, any questions? Yeah.
How would one go about integrating their own software and service to fit into the OpenStack?
Good question. Okay, let's go back to the architecture slide. If we can find that slide. There it is. Oops. Oh, okay. Did all that work and it. Okay, so each one of these components, the way I drew this is I just drew a line here and said, okay, you got your API interface, the RESTful API. So each one of these components actually has a set of RESTful APIs. Some of those are built, tied in through this shared service to say, launch a new instance. Okay, and then underneath the covers, it calls all the different components. So you got to if you want to program this in, you go in and you're going to create your service and call those RESTful APIs. Okay, so if you're trying to create some software package, that's what you're typically going to do. Now, if you're down underneath, you're going to build a plugin or a driver. You're going to interface into these components from the bottom. So you can build in or on around OpenStack from the top or the bottom, depending on what you're focused on.
And the documentation's on the website?
Oh yeah,
Okay.
tons and tons of it. There's books. In fact, let's see. That's off topic. Yeah, there's mailing lists, there's IRC channels. What I was going to say is typically we talk about, when we say open source, we're always talking about source code. In this case, we actually have a lot of documentation writers, and they actually even wrote a book, and open sourced a book. under the Creative Commons. So there's a couple of them out there. There's an administrator's guide, there's an architecture guide, there's the API reference, so there's a whole bunch of stuff.
Nice.
That's pretty sweet. Good question. Other questions? Yeah?
DevStack?
Yeah.
I don't know much about it. I just heard about it today. So how is that related?
So DevStack is, I would say, think of it as an implementation of this in a testing environment.
So similar to the Easy Cloud thing that you were just, you kind of put it up in a VM or something like that, or?
Yeah, actually, so that Easy Cloud that I just referenced there is this whole thing. It's actually this whole thing. So you've got all of OpenStack plus all of this pieces here, and what it's going to do is run the install. Okay, so the difference is when you go back to OpenStack, if you're just running these pieces, it's going to ask you about 1,000 questions, and you got to set up. Well, it's not going to ask you 1,000 questions. You're going to have to fill in about 1,000 parameters to do the configuration. That's why they built this piece. It's going to ask you a couple questions.
Okay, and so DevStack then is somewhere in between that?
So DevStack is somewhere in between there. So DevStack is what a lot of the developers use to check their code before they check it in.
Oh, okay.
It's
so not so much for like a developer like me writing my software that I can test how it gets deployed.
You can do that.
Oh, okay.
You can do that on DevStack. It's going to be harder to install than this,
Yeah.
but it's not that hard. If you go out on openstack.org, you'll see instructions from Susa. Susa has instructions out there, Red Hat, Ubuntu, Rackspace. There's a whole bunch of them that says, here's how you do DevStack on top of SLES and RHEL and RDO and Ubuntu and Debian and so forth. It's harder to do, but so it's in between.
Okay.
Other questions? Okay, thank you.